Good afternoon, sir. Esteemed examiner, sir. Um, my supervisor, Professor Ashish Srivastava, sir. Uh, DRC members, honorable DRC members, and all my colleagues present over here. Yeah. Screen share. Yeah. Screen share. Am I audible? Sir, am I audible?
Yes. Yes. Yes.
Yes, sir. So myself, Himanshu Priyadarshi, uh, and my topic for today's PhD viva examination is a state estimation technology for energy storage device management systems. I have been working since 2019 under this topic under the supervision of Professor Kulwant Singh and Professor Ashish Srivastava, sir. As far as the contents of this presentation are concerned, they will proceed in this manner. First of all, I will talk about the introduction. Then, first of all, I will talk about the introduction, the motivation of the work, which keep me going, and I hope it will propel me further also because I find this topic to be very interesting. Then the literature review, which culminated towards the research gap identification and the definition of the problem. Then the methodology adopted and outcomes which have been aligned with objectives, and then the publication, and finally the conclusion. When we see this diagram,
Sorry, but I'm not able to see the slides. Can you share again?
yes, sir, I will reshare.
Himanshu, your screen is not visible, only you are visible.
Okay, I will reshare, sir. It's a problem here, sir. कनेक्ट हाँ वो कनेक्ट कर रहा हूँ 1 मिनट पहले स्क्रीन शेयर Sir, is my screen visible now?
Yes.
My
Yes.
slides
Now
visible?
Yes.
Thank you, sir. No, this is the introduction. Am I audible? Is my screen visible, sir? Just again checking once.
The screen is visible. Keep it in the PPT mode.
Yes, sir. Is it in the PPT mode now?
Yes, yes. Yes.
Yes, sir. So, whenever I thought of battery before undertaking this research, I always used to think of it in terms of its Thevenin model. Like, even when the battery is sold to a customer, also what he sees is the voltage rating, any battery in the market, or for that matter, any energy storage device. But as I started researching in this topic, I realized that there's much more to it. Just like when we see the AC outlet, we think that it is 230 volt 50 hertz. We the natural thought which comes to the mind is that a battery is just about its potential difference. But here we can see that as it has been presented by a research group, it is much more than that. The research group has identified pertinent lumped circuit parameters like resistance, capacitor, and then have modeled it. So resistance is there, resistance associated with the positive grid is there, resistance associated with the negative grid is there, the capacitance is there, the active material is there. So battery is much more. So this naturally propelled me to think that one has to work at the device level, at the root level of the battery. And then of course there are three pertinent parameters in anything. First is it's how we procure it, so generation, then the operation, and then it's recycling. I have on purpose I have not used destruction because nature naturally operates on the concept of recycling. So all these three parameters has to be taken out, and that is, if I try to explain it in a crux, that is the motivation and that is the introduction of it. So this was the previous schematic, and I have, in this slide I have tried to explain the basic components because it will be useful as I develop the story of this. This is the cathode of a lithium ion cell, where the purple balls, they model the lithium ions, and then it is sitting snugly into the lithium LMO or its active material composite there. And this is the anode, where these, again, the purple balls represent the lithium ions or the lithium atoms, and these two-dimensional network, it represents the graphitic layers. And of course, whenever there is a battery, apart from the electrodes, there will be the electrolyte. This represents the salt. And then the separator. The separator is meant to ensure that there is galvanic separation, although there may be ionic exchange between the electrode and the between both the electrodes. The market size is simply humongous because energy storage devices are practically ubiquitous, whether it is Internet of Things or wearable electronics, RFID patches, handhelds, or electric vehicles, or renewable energy storage applications. They are everywhere. And the range or the functional capacity in terms of ampere hours, also it varies from milliampere hours to greater than kiloampere hours. And the features are also variegated based on that. Now coming to the motivation, every time, particularly when I go for a petroleum refill, I look at the meter. It's very costly and it is at the verge of extinction. And global pollution casualties, they remain unbridled more than any other thing, more than any natural catastrophe, more than any terrorist attack. The pollution calamities, casualties, they remain unbridled. But side by side, since we are living in a progressive world where we are all interested in improved standards of living, we need more energy per capita. Another motivation was, when I was studying power electronics, I was simply surprised to know that why power electronics devices are required, because the amount of power which is generated, only 1/6 of that reaches to the consumer end. And of course, energy security is also required, which is very important for any nation. And finally, the motivation was that, being an engineer by profession, I must contribute in my own humble capacity for technological support system for efficient energy conversion and storage. The motivation we can see, again, this picture represents the fog in NCR and the traffic jam there. So e-transportation is also a sector which motivates us to work in batteries. Environment friendly mobility, economic mobility, quality, comfort, swift acceleration. And the bottom line is that the consumer, the customer, he is not much concerned about the inside of it. One of the main motivation of a consumer or a four-wheeler customer is that the quality and comfort should not be compromised. So finally, if we come to a summary of this, previously I used to think that the empathy for ecology and environment and the pressure of consumer economics, this is a dichotomous topic, but actually it depends upon our attitude. It's about convergence also, because if for example, we say that an engineer must have a societal sensitivity and environmental empathy. But unfortunately, when he gets into the research, he is forced by consumer economics. But can we dovetail consumer economics into environment and empathy? Of course, it depends upon education. So if we do that, if we think this as a convergence and not a dichotomy, then the quadruple bottom line of corporate social responsibility, that is the profitability, people, planet, and problem solving platform, all will be achieved. So coming to the literature review part of my work, when I was researching the literature for problem formulation, I identified pertinent factors in this. For example, what is the reaction kinetics of the energy exchange? For example, when we talk about lithium ion cell, what we know that lithium is a lightweight metal, and it is very amenable to release that electron, because as soon as it releases that electron, it becomes stable. So reaction kinetics have to be concerned. When we get into the transition metal oxides of different kind, we need to consider that. Second consideration is that if I am introducing something in the electrode composite, whether it will be accommodated in the electrode matrix or not, that also has to be considered. Then I have emboldened this ease of availability. This is very, very important in my opinion, because we should not be dependent upon some technology which we have to import, because it completely stifles the economic system. So ease of availability, indigenous availability is very, very important. Coming at the device level, the open circuit potential manifested, the stoichiometry, and at the end of the slide, I will of course talk about this, that we have been successful in designing an electrochemical coin supercapacitor. We will show that. The stoichiometry, for example, lithium loses just one electron, but if one of the important aspects of our energy management is in this work is iron ion nanoparticles. There it has two states, so that also has to be considered. Choice of the method for electrode material preparation, is it very costly? What is it the contribution to device materials of the material selected? The thermal stability, how the conductivity changes when we shift to nanoscale, amenability with respect to state of health estimation, reusability, application, whether the material is application specific or versatile. And again, the point where my pointer is rotating, waste disposal is very important. Recently I read an article in a technical magazine. There it was saying that there is no need now for rechargeable batteries. Of course, it was just a title to attract the attention, but the promise was that you purchase a nuclear battery that will last for 50 years and you don't need to recharge it. But the problem is that how to dispose that? We know that nuclear energy is very, very uncontrollable and very, very risky. So that is important thing. Then waste valorization. Can we derive value from the waste? So this is very important. And again, I was talking about lithium ion cell, but is lithium ion cell everything, or is shall we just resort to only this option? Of course, it has advantages. Lightweight and compact, energy density is very commendable, charge retentivity is high, but more number of charge discharge cycles, operating voltage is higher, but there are disadvantages, and as we go further, the disadvantages lie here. For example, I will like to read this. It is a very water intensive process. Brine extraction is a particularly water intensive method. Brine, by the way, it is one of the principal source of lithium, and it is using an estimated 500,000 gallons of water to produce just 1 metric ton of million. And there has been reports of aquatic ecosystem damage because of the use of that. Then recycling processes still remain costly and immature. And the misconception that I will not call it misconception, because there are debatable theories on that. But what this report says, that 14 million tons of lithium is left, which correspond to 165 times the production volume in 2018. So we need to think of alternative materials. And in connection with the previous slide, we can see that we should not tolerate environmental damage. Why? Because all the parts of the environment, they have feelings, and it is our responsibility to protect them. And if we dodge this responsibility, we will not be able to dodge the consequences of dodging that responsibility. So what are the alternative materials? Transition metal oxides have demonstrated good prospects. Why? Because of congenial Faradaic reaction taking between the derived electrodes and electrolyte. However, they are costly. For example, cobalt, manganese, tantalum, and these are all very costly from an environmental vantage point. But out of these, iron is very, very useful. Why? Because it is easy to procure, can be derived from waste, and they are ecologically benign also, as we have seen that the methodology used to make them is very, very good and environmentally congenial. So the point I was making here is that when we use iron oxide nanoparticles, or to be more precise, gamma Fe2O3 nanoparticles, megamite nanoparticles, the oxidation state modulates from ferrous and ferric, ferrous Fe2 plus and ferric Fe3 plus, making it capable of catalyzing abundant electron transfer. So that is also a good part of this, and people have demonstrated iron ion batteries. So, and another aspect is that it is amenable to state estimation. For example, the change of from ferrous to ferric, or the, as we go further we will prove it, and it is one of our novel contribution how we have proved it. So coming to the aspects, what are the different aspects? Just wanted to have totality of the picture. This is the battery, this is one of the cells, and we want to make cell from waste, right? And we want to gather that data, and we want to share it openly. It's not that we will keep it secret. It's not a medical data which needs to be federated. Of course, when things scale up, there might be arguments for that. But this is such a data, and even if it is federated later, let us say that their data is federated, that is not a problem. At least the skeleton will be available. And what I feel, my gut feeling is that if we take such an approach, we will be having a lot of benefits, including profitability, battery longevity, and optimization between all the parameters of state estimation. Now coming to states, because this was about this was a literature review regarding the procurement. Now state, what are the different states? State of charge. State of charge generally from a macroscopic point of view, from an electrical macroscopic or electrically observable point of view, state of charge is ratio of the amount of capacity of the charge remaining in the battery amount upon the rated capacity. State, similarly, other things can also be defined. And this diagram shows that when a supercapacitor cell or a battery cell, it is being charged, current flows into it, and when it is acting as a source of energy, current is flowing out of it. So now coming to research gaps, having defined the states, having defined the procurement limitation, the material considerations, the research gap is also identified in two parts. This one pertains to the material side, material engineering aspects. So the gaps, as we can see, that although researchers have synthesized iron oxide nanoparticles, but they have not done the doping studies except one, and none of them have done magnetization studies as far as the energy storage considerations related to. Moreover, the band gap studies also have not been done. So these were the gaps, and as far as the state estimation is concerned, these are very recent references. The error metrics, if we see, mostly they have limited to mean absolute error or root mean square error, but they have not gone to collate it, and they have not generalized their model, nor they have included the time complexity studies. So with this too, we have identified the objectives also, and the definition of the problem, I will like to read it. Affordable energy storage is indispensable for attaining the sustainable development goals. Why? We have the ambition, of course all of us are ambitious, that the modern power system should be 100% renewable. Cent% renewable power grid is required. So for that, if we are targeting that, affordable energy storage is indispensable. And In that, longevity, reliability, frugality, and convenience of manufacturing are very important. Why? Because the battery has to be long lived. Reliability should be there. And each of them is a separate research topic. Frugality and convenience of manufacturing is also there. So the problem formulation for the work done in pursuance of this doctoral thesis has been done to contribute towards creating indigenous batteries equipped with features that can support state estimation for ensuring return on investment for the cost incurred in procurement as well as utilization of energy storage device. And this is our overall vision. It will be so nice if this can be implemented to a more robust and more realistic way. Objectives. So our first objective was to explore fissile materials for energy storage device management and to improve their accuracy. And as far as the state estimation is concerned, to simplify the time component, to investigate the efficacy of machine learning techniques for energy storage devices. This was objective number 4. So the methodology, again, to summarize it: choose materials which are locally available, synthesize the precursors, of course, and synthesize the energy storage materials with a state estimation amenability, and use a data-driven approach. Why I am pitching in for data-driven approach? Because today we have a lot of computational power availability, and so reductionism is okay wherever required. It may be application specific to use a reductionist model, but data-driven models have a lot to offer in terms of detailing, and sometimes by paying careful attention to details we can get things which would have been ignored otherwise. So coming to objective number 1, what are the contributions? So while exploring for fissile materials, we devised a method with which we synthesized our nanomaterial, energy storage nanomaterial. And this novel process sequence optimization has been done in our lab itself, and without any costly, we didn't have to procure anything new. And scalability has also been explored after the comment by the honorable examiner. We have also recently explored that it can be scaled up to 6 times, and moreover it was time invariance also. So what we did, we took the precursors, and then the stirring was done at the given specification, then the doping was done, and then the alkaline was added and allowed to settle it. Then the filtering, once the sediment was formed, it was allowed to be filtered, then cleansed, dried, and finally it was ready for being characterized. These are the different parameters and their workable ranges. For example, the alkalinity of the titrating agent was kept from 8 to 11. Temperature of sample preparation was from 330 Kelvin to 360 Kelvin. The speed of stirring was at this, like that. And then these are the different parameters, like what was the doping level, what was the temperature. 4 samples, we have been mentioning 4 samples, and their particle size. The particle size have been in nanometric level, which was very encouraging for us. And of course, as far as the characterization goes, we go for, first of all, the fingerprint. The XRD, often by material scientists, the XRD method is called the fingerprint identification. For any material, the reference is there. We need to validate whether the material has been formed or not using X-ray characterization. Side by side, we have also done band gap measurement. Why? Because if we see the band gap of our materials, the maghemite nanoparticles, iron nanoparticles, at bulk level it is 2.2 electron volt, but it has shooted up considerably. So this conductivity modulation again proves that this is amenable for energy storage material. For example, if we go to the introductory slide where I was referring that schematic of the battery, even the active material of the electrode contributes to the resistance when it is connected to the grid. So all these parameters has to be considered. After all, what is resistance? Resistance is as a lumped circuit parameter, we say that it is resistivity length upon area. But what is resistivity? It is resistivity depends upon the mobility, the mobility of the carriers, and other parameters, other microscopic parameters. So if we see the band gap for the first sample, we obtained a band gap of 3.91, which is nearly two times in comparison to the bulk sample. Now this is transmission electron microscopy results. Why we go for transmission electron microscopy results? It gives us more conviction. It gives us more conviction regarding the formation of the size and the fidelity of the materials which is found. Using TEM, if we can make a comparison, the crystallite size which was found out using Schirer's formula, that was 5.5 nanometer with an error of 0.8, and using transmission electron microscopy it was like this, 5.125. It was, they are nearly in agreement with each other. So what we do here, we get the image, and there is an image software which automatically gives us the calculation, the standard size and error, everything it gives. As far as the XRD calculations are concerned, we use Schirer's formula. For example, let me go back and try to explain this. This is, for example, this is the max, this is the peak. I will calculate the half of the peak, and using that I will calculate the particle crystallite size. FSM also, it is field emission scanning electron microscopy, that also confirmed our results that the nanoparticles which are being formed are in the nanometric range, and the constituents were also in agreement, like iron, zinc. Zinc was of course the dopant, iron was of course the main precursor. Now coming to the alignment with the publication, to this objective we have filed one patent which is under examination. We have 2 journals, and we have these book chapters and conference proceedings. Now with your kind permission, I will come to objective number 2. State emission amenability. Here we need to check the state emission amenability. So the basic philosophy was that whenever we are trying to develop this method, the novel method which we have claimed, what are the advantages of it? For example, if we have affordable batteries, it will increase DG penetration. DG stands for distributed generation, and it will overcome the dependence on costly electrochemical energy techniques. There will be more return on investment. Okay, it will reduce the carbon footprint, lesser life cycle costing, better safety also. If it contributes to the accurate state estimation, if the energy storage nanoparticle which has been synthesized, if it contributes to better state estimation, naturally it will raise the flag that okay, the state of charge it has gone to dangerous levels. Okay, so that is one advantage. Better prognostics when a battery has to be replaced for being recycled, and all these characteristics. But how we attain that, that is what we are going to establish in this. If we see, I told during the research gap identification, I mentioned that magnetic characterization was one important gap which we have addressed. Why? Because we have done magnetization using VSM, that is vibrating sample magnetometer, as well as SQUID, superconductive quantum interference device. So why we have done both? The natural question which comes is this: why? Because SQUID is used for lower temperatures, as we can see, and here the magnetization, we can see it varies from 53 to 61. Generally for the bulk it is much lesser, comparatively lesser. And here also the MH curve we are seeing over here, it is quite linear. We will zoom it in the latter images and see how it is quite linear. And before that it was not done. So we feel that particularly in the context of energy storage device materials and technology, we have addressed a very important gap. So we can see here that this is quite linear, and this linearity is very, very important feature as far as the state estimation is concerned. And we have calculated some metrics from the magnetization versus magnetizing field intensity curve. The saturation magnetization we have calculated for the different samples. The coercivity also we have calculated with respect to the different samples. Compared to the bulk, which comes up to 50, or sometimes it may be 60 depending upon the, but it is very much comparable. And what we are more interested is the linearity of this curve. And going further, the thermal characterization also has been done. Why thermal characterization is important? We take any device, any electronic device, it becomes hot. It becomes hot. And there are local hotspots. It is a pertinent power electronics problem. There are local hotspots everywhere. So even in batteries, they also become hot. Recently, I was testing the Quine supercapacitor cell. It became hot in 1 or 2 minutes, actually. Anyway, so the point is that if we see this material, here we are observing a kink at much higher temperature, 400 degrees centigrade, and for here at 600 degrees Celsius. Otherwise, it is more or less stable. More or less, it is thermally very, very stable. So we started with objective 2. The motive behind objective 2 was to prove that our state estimation amenability of the materials which we have synthesized is convincing, and using thermal and magnetization characteristics we have attempted humbly to prove that. Towards this also, these are the publication. Objective 1 and 2 are quite related. So these are the book chapter and the conference proceeding and the journal. This journal is in Material Science and Semiconductor Processing, and this is this one is in Critical Reviews in Solid State and Material Sciences, and the third one is under review. We have received very minor comments, and we have communicated the comments. We are very hopeful that soon it will be accepted. Now the third objective number 3 and 4 have more to do with macroscopically observable effects, like am I able to get better time complexity for state estimation? What is the time complexity for the state estimation? Now if we see this, this is my energy storage management system associated with the appliance. Let us say this is connecting with different energy harvesting equipment. Related to every energy harvesting equipment, there will be a power conditioner. For example, if it is a solar panel, there will be a DC to AC converter. If it's a wind based energy harvesting equipment, there will be a power conditioner of another nature. And then when the energy storage management device interacts with the grid, there has to be an energy storage to power grid coupler, and there has to be a power grid to energy storage coupling. And honorable examiner, he motivated me to add this block diagram, that what do I mean by this EST PGC can be explained using a block diagram. So that also has been done. So this one, if we see, for example, if we take a cell and observe its charge discharge patterns over a given span, because when we talk about charge discharge patterns, it can be over one cycle, charge discharge cycle, or across different cycles. Of course, when the state of charge is calculated, it can be calculated either across a charge discharge cycle, but when the state of health is calculated, it spans across different charge discharge cycles. So this is a time domain description of cell potential graphically represented. Like what does it mean that C rate of 7.5? For example, a C rate of 7.5 implies that if the cell would have been discharged with 7.5 ampere current, then it would have been functional for an hour. And if the same cell would have been discharged at 15 amperes, it would be functional for half an hour. So time complexity is important. Why? Because, for example, let me explain it why it is important. I am driving a car. It's a very, very pertinent, but drives home the point. I am driving a car, an electric vehicle, and my meter is not able to show that the battery state of charge is low. then that is very, very dangerous. Therefore, accuracy is very important, and moreover, the timing is very important. So what are the factors which affect the execution type of a generic algorithm? Time complexity, space complexity, protocols and devices for communication, speed of the processing unit, and these are the different factors which we need to care. But of course, we are talking about the execution time. Why execution time is important? Because as far as the implementation of the approach which we have considered for simplifying the time complexity, we have considered certain parameters. The approach which we have used, let me define. In the coming slides, I will be the length of the input sequence, R be the dimension for representation, C will be the convolutional kernel size, and P will be the proximity size in case restricted awareness is required. This is our architecture actually, which we have claimed. So generally the data given to it is a time series data. That time series data, then it has to be processed, it has to be vectorized, and then this is a linearly connected network, which is fully connected network, linearly linked network, and then there are different pooling models. Why I'm not using only single? Because there are advantages of it. When we use parallelization of individually aware parallel models, what happens is that our time complexity decreases, and finally again it is linearly connected. There is scope for superposition and normalization again during representation, okay, and finally encoding, and then the probabilistic output is stored. How it works, how this architecture works: the input sequence from the data procured along with positional encoding is then vectorized and passed on to a fully connected layer or linear layer, and then it is passed on to identity awareness pooling monolayer. These are the monolayers of parallelization. Awareness means that it is aware of its vicinity. People use different names for it also. Sometimes they use attention mechanism, but we have on purpose used a different name because of different functionality and novelty over here. So instead of training the data on a monolayer, it is parallelly pooled to such multiple monolayers along with scale data product, and then parallel pooling is done, and this parallelization is meant to ensure that the training of the machine learning model is fast and multifaceted. And finally, we have used, as far as the activation function is concerned, we have used a softmax neural network layer there. Okay. Reason being, softmax is differentiable and easy to compute gradients, and it is very helpful where probabilistic output is being given. So what is the workflow which we have used for this architecture? We have appended the data received from the sensors attached to the hardware with historically data collated from variegated geographical sources, and then used statistical tool to perform data pre-processing, which might involve data cleaning, feature extraction, and analytical insights. Then the data was split into training, testing, and validation ratio, and empowered the proposed architecture to training, testing, and validation in multiple epochs for obtaining the best possible accuracy of the error matrix. And this is a simplified machine learning model. Here, alpha VGS represents the parameters of the pre-trained model. LOF NPM represents the loss function. TRDS represents the training data set collected from various geographical sources. And alpha VGS is the learning rate. So what we do is that we fine-tune our model based on learning from different models. Actually, the basic philosophy of this is very, very simple. In fact, the basic philosophy of machine learning has been utilized over here. It is not very difficult to understand, although it might look complicated in terms of mathematical model, and it looked to me also. But what happens is that machine learning, as defined by Tom Michel, he tells that machine learning is very simple. Machine learning, only three parameters: experience, performance, and metrics of performance. So the more a model becomes experienced by training it on different data sets, the better performance measures are expected. Therefore, this philosophy of cross-domain learning, which we have detailed here, that comes. And when we have, of course, represented only pertinent results here, there are many other methods by which we have done it, but we have represented only pertinent methods. Why? Because we wanted to find the asymptotic time complexity. For our algorithm, it is of the order 1. Why it is of the order 1? There is a reason for it. The reason being is this: because individual awareness pooling stratums joins all positions with a fixed number of sequentially executed operations. Therefore, it is of the order 1, constant. But if we see recurrent neural network, it is directly proportional to the number of inputs. Similarly, if we talk about the asymptotic time complexity per stratum, here in CNN, the convolutional kernel size comes into picture. But here in our approach, we can modulate it. If we are interested in less awareness, we can modulate it that way also. So the publications and outcomes which are aligned to this objective, this is a different patent which we have filed. There are conferences, book chapters, and this is again the journal article, and this is a communicated one. Now coming to the fourth one, what are the prospects of machine learning for energy storage? It's not that it has not been done. People have used support vector machine neural network towards this, and they have concurred that it is better to use data-driven models for completeness of representation. So what are the metrics? We have identified certain metrics on which we have compared our results. Mean square error, it has been used because it is very significant to establish the identity of the risk function in a quantified way, and particularly when the second order phenomena has to be captured, it becomes very, very important. Why? Because let us say a battery cell is being heated. It's a second order phenomena. Why? Because the cause is the voltage, local hotspot voltage, and the effect is the current, which is dependent on the voltage. So it's a second order phenomena. Root mean square error, why we are using? Because it is very significant to establish the quality of prediction by measuring the deviation from the ground truth, right? And it's compulsory to use root mean square error for standardized data, as our root mean square error is not a scale invariant error metric because of its intuitiveness, compatibility, statistical amenability. It is very, very powerful tool. And why we use mean absolute error? Because it is very significant. Now what happens when we are using mean square error and root mean square? The penalty is also of the second order. So this is mean square error is also important because mean square error is in linear correspondence with predicted target values. Another important aspect is coefficient of determination, particularly for our work. The work being proposed herein is very important, coefficient of determination. Why it is significant? Because it establishes the measure of variance in the dependent vectors, which is possible for the independent vector to explain. And mathematically, it is defined as the ratio of sum of squares residual errors and sum of squares total, where sum of squared residual errors denotes the cumulative variation of all the predicted values available on the regression curve, and SST, it signifies the cumulative variation of actual values from the mean value of all the instances of response variables. The value of R squared error, coefficient of determination, is between 0 and 1 for the training set, and higher the value of R squared, better is the regression model. If this factor becomes negative, it means what? It means SSRE exceeds SST, right? And why it is important? Because if we want to predict the quality of a predictive model, this is very important, because we are collating data from different places. We have our own data sets also, we are collating it from different data sets. So in that case, it is very, very important to use it. Another two important parameters are skewness and kurtosis. Skewness establishes the degree of asymmetry in the collated data from various sources apart from the local data set. That's why we have taken this. And ideally we will want that skewness is between -0.5 to 0.5. and we can deal with it. It's not, it is an something, it is something which cannot be dealt with, because by applying suitable transformation techniques we can deal with it to make a normal distribution. As far as kurtosis is concerned, this is another metric which establishes the degree of the presence of outliers in the distribution of the data set, and it will tell whether the normal distribution is heavily tailed or lightly tailed. High kurtosis means high risk of prediction, low kurtosis means low risk of prediction. So in terms of this, these are the results for CNN and RNN. These are the different values of MSE, MAE, and our the proposed algorithm is giving better accuracy in terms of MSE, in terms of mean absolute error and root mean square error also, and R square error nearing 1 as we go back. If we go back, the ideal value is 1. So this is very much desirable, it's near 1. So these are the publications related to it. We have a patent of course, this patent also is related with objective 3, because objective 3 and 4 are related. We have a journal, and this again is communicated. These are the book chapters and conference proceedings. Now coming to the response of examiners' comments, which I will be answering as I proceed further. With due respect, sir, I am really grateful for this comment, and I have curtailed my abstract to 2 pages to ensure that essence is not compromised, and at the same time it is compact. I have scanned my thesis. The second comment was that I should refrain from using IVS. So what I did, I found out nearly 16 instances, mostly it were in first chapter, and I searched all such strings and removed them in compliance with this very important comment, sir. The third instance was that references should be mentioned below the figures as a caption for which are taken. Sir, actually these figures, they have been generated by me on a simulation platform, MATLAB. And have not been taken from any references, sir. The fourth comment was that I highlight the gaps in the previous work. So, sir, this has been done in table number 3.3, where I have highlighted the gaps, and this was the same table which I used for my objective formulation, sir. This comment was that the author should include the schematic of EST, GP, and PGTES before 4.4. Thank you very much, sir. This was very important for me, and I realized that it will add value to this figure. So I have added the block diagram of the energy storage to power grid coupling, where this, after the energy storage devices, there is an energy storage device management system, which is an integral part of any storage devices. Then there has to be a DC to DC converter. This is the power conditioning module here. And then there is a grid synchronization unit, the transformer, protection and control circuit, and interface for connecting to the grid. The second is power grid to energy storage coupling. So from the grid, there will be a transformer, then the power conditioner, rectifier, a DC to DC converter, and then the energy storage devices along with its allied management system. This was, I am very grateful for, of course, all the comments. They have considerably enriched my work. And this comment was that I do claim that this setup is cost effective, but I realize that with this comment, I need to see that whether it is scalable or whether it will remain cost effective even if it is scalable. So, sir, after I received your comment, I started working in the lab. This is an orbital shaker where I have scaled it up 6 times the original volume and scaled it up. This is an orbital shaker, and for the steering, Of course, I have not used the magnetic bead stirrer which I use for my sample. This is an orbital checker. Luckily, it's available over here. And this is the oven. Then I dried it, and this is the FSM image. And again, sir, other results are also awaited. And since FSM has confirmed that, I am very much confirmed that the nanometric results will be obtained, sir. The next comment was that I should compare the samples reported in chapter 4. So, sir, mostly the results are comparable, and the method which has been proposed in chapter 4 gives slightly better results in some aspects of particle size and band gap. Sir, thank you very much. This comment actually established the link, and as per your kind input, I also felt that chapter 4 and 5 are slightly disconnected. Therefore, I have, after talking about material properties, I have just added this paragraph, and hopefully this will serve as the desired connecting link between the two chapters. What is the full form? The ninth comment was, what is the full form of ECM, EBM, DDM in chapter 5? So I am very grateful for pointing this out, and with all due respect, I will like to humbly submit that whenever I have used it, what I have done, I have defined the expansion of the acronym at the very first instance, so that there is no ambiguity. So the very first instance where I have used it, I have just corrected it. ECM stands for equivalent circuit models. Equivalent circuit models, actually, as I told in the very beginning, a battery, we look at it as a open circuited potential difference plus its series resistance, but there is much more to it, right? So different researchers, they have given different equivalent circuits. So the problem with equivalent circuit model is that they are reductionist in approach. Therefore, there are electrochemistry based models also. But the problem with electrochemistry based models is that they are electrochemistry specific. Let us say one company is manufacturing a battery, he will give a model that will have, its data sheet might be having all the different parameters, but again, that will be specific to the electrochemistry. But data driven models will be more generic, hopefully. And DDM stands for data driven models. Comment number 10 was that how solar and wind related discussion is valid for battery state estimation in section 5.4. Sir, in section 5.4, the discussion related to solar and wind parameters is done in the context of exploratory data analysis. In this section, prediction of insolation of course stands for solar radiation received, has been done using regression tool of machine learning, which is being demonstrated, and it is directly correlated with the state estimation of the battery. And this data set has been used from different data set, one such being the openly available data set from MNIT Jaipur. So the next one was that the limitation of the contemporary battery management system stems from the fact that these battery management systems have been designed from an islanded approach targeting a particular electrochemistry or application. Does this mean electrochemistry and corresponding state of charge will change depending on the nature of the input supplied to the battery storage system? I have tried to answer this, sir. Actually, with reference to the statement excerpted herein, it may be stated that different battery cell models are generally designed based on empirically derived parameters of the specific battery models. There is a lot of approximation in such reductionist approach to modeling. Such battery models vary for different types of batteries. There has been consistent improvement in the accuracy and speed for the model-based online estimations of state of charge and state of health for batteries. Nonetheless, the necessity to strive for optimal solution, striking a desirable balance between accuracy and computational cost, can hardly be overstated. Data science techniques coupled with machine learning approach have heralded the deployment of data-driven models which can predict state of charge and state of health agnostic to the a priori system knowledge. These data-driven models make use of machine learning approaches like regression tools, support vector machines, neural network, random forest, etc. for the prediction of state of charge, state of health, and remaining functional life. Thus, it cannot be overemphasized that accurate data sets for causal as well as acausal cell parameters will help to adopt the best practices in manufacturing, uses, and optimization of energy storage devices. The electrochemistry is battery specific and plays an important role in state estimation in an electromechanistic way. This statement must be interpreted in the light of emphasizing the relevance of data driven models for different types of batteries spread across the spectrum of available energy storage technology, and advocates the generalizability of the data driven modeling, sir. So the point is, the last statement I have just tried to summarize, that uh, data driven models for different types of batteries spread across the spectrum of different available energy storage technology, and hence the purpose is generalizability. Comment number 11, how solar and wind related discussion is valid, that I have already discussed, I guess. Now, coming to the comments by Honorable Examiner 2, mostly I am very grateful for the remarks, for his encouragement. They are mostly positive. Honorable Examiner 2, sir, has given his comment on abstract, then chapter wise, chapter 1, chapter 2, and he has very crisply captured the essence. And finally, these are his concluding remarks, sir. So, and these are different publications. And lastly, I am very grateful that to the industry support I got because of my mentors. And I have received funds, one from Sri Balaji Engineering Works Jaipur of worth 3.54 lakhs, and we have completed this. And the second one is from High Green Carbon Limited, 5.9 lakhs. We are working on it. And in summary, this is our work. Actually, I am very happy to inform that we have now come to the device level. This is a coin cell. Coin cell is the casing, but this is a super capacitor, and we obtained like this. What I have displayed is 1.322, and I have done 3 experimentation. In another active material I got up to 2.5 volt, and with another active material I got up to 3.2 volt. So what we do, we make the active material. There are 3 approaches for making the active material. We have used a particular one, and then we have coated the active material. This is a copper current collector, copper foil, and this is an aluminum foil. Coated it, dried it, and finally fabricated the super capacitor cell. So this is my conclusion. The entire approach is 2-pronged from the point of view of material science engineering and from energy management. So the first one is regarding this point number 1. It captures generation of or procurement or fabrication of an energy storage device, and then it's recycling. And second one is about maintenance, because even we say that it is easy to create thing, not easy, but still it is comparatively, it is easy to create something, it is easy to destroy something, but generating something in a recyclable manner, that is very important. And even more important is maintenance. Maintenance is very important. So my philosophy, my understanding is to use data driven models, because we have the computational power, and both of these will interact with each other and learn with each other. So I am very much thankful. Sir, I am done. Thank you very much for hearing me patiently. My examiners, sir, my supervisors, and my honorable DRC members, and my colleagues.
Okay, so Himanshu, it's a very nice presentation, and you have actually covered most of the things which were there.
Thank you.
So from my side, everything is okay. Just one last note regarding during presentation, you mentioned in slide number 37 something about magnetization characteristic, MH characteristic that was there in respect of some samples.
Yes, sir.
37, yeah. So I'm just wondering, uh, it's, you are doing this characterization for a material which is meant for energy storage, and that too is more or less kind of um, a capacitive, or you may say some batteries, etc. So what made you to just go for the magnetization characteristic of this particular material?
So actually, it establishes the linearity of the material. Like if and once it is linear, let me explain, sir. What happens when we try to measure the state of charge? One approach is the atomistic approach. The researchers have defined, experts have defined the state of charge in an electrode as the amount of ions, let us say how many ions, how many lithium ions, if it's a lithium ion electrode, how many lithium ions are there. But to measure that is very, very tough. So that is the atomistic definition of a state of charge. Another definition, if we come to electrically observable definition, it says that present capacity, remaining capacity, and the rated capacity. But what happens is that we need, if we in any energy storage cell, if this can be sensed, if this can be sensed, that whether it is linear or not, it is exhibiting linear characteristic, it will clearly prove that the active material is still active and is still contributing to the electrode matrix. It is still contributing to the electrode matrix. So that is the point over here, sir.
So yeah, does it actually affects the uh, or decides the, let's say if I'm getting a slightly different slope for the same material, how it will affect the capability of the material?
So what I feel is that, of course, we need to do further characterization at the device level to uh, get more empirical conviction. This is one preliminary precursor level empirical conviction. But as I told that we have synthesized the supercapacitor's coin cell also. As we go for further characterization, then things will be more clear. But as of now, what will happen if something is linear? Something is linear, it means what? For little change in H, the way it rises, the magnetization rises. For little change in H, the way magnetization rises, it tells me that it is sensitive to this change in H. But if the slope changes, the sensitivity will also change. Like it can be understood, rather crude example, but not so crude, in terms of sensitivity of a sensor. In that sense, I am talking about the linearity of this. Of
Okay,
course,
thank you. That's it from my side. I think that's a very nice presentation. Everything well done. You have covered the comments of both the examiners quite well, and you have addressed them in the right manner, quite confidently as well. So I congratulate you for this work, and I hope from my side I can certainly recommend you for the PhD award degree. The rest the DRC will take care of.
Thank you so much for your kind words of appreciation, but the credit goes to my mentors. Uh, you can see Professor Kulwant sir is there, then Professor Ashish sir there. Although Kulwant sir is hospitalized, still he has taken the pains to join this. Ashish sir is also not well, still he is making all the arrangements, and we have here with me Dr. Dhaneshwar Mishra sir here, and then my STC member Dr. Amit Soni sir, who has been supporting me right from the beginning, and my departmental HOD, DRC coordinator. I'm very, very grateful. Thank you for your.
I think I would like to say that the queries from any of the DRC members, DRC chairman,
Yes, sir.
any queries for the presentation?
Nothing, sir. We have
Dr. Amit
already
Soni.
discussed while pre-synopsis presentation.
Correct.
So I think it is basically this presentation is for the external examiner. Basically.
Correct. But still, if anything is there, that's why I asked. So
So I request all the
I
members who are present to offline or online, if they have any query, please.
I could not hear. Is this question for me? I don't know.
I think there is no query, sir. One request is there, sir, Santosh sir, because the presentation is conducted in the online mode. So your recommendation should be received in the online mode directly to the COE. So please send your recommendation by today to COU, and also keep in loop to me and also our chairman, sir, Sunil Kumar Goyal, sir.
So is there any template for all those paperwork?
No, sir, there is no template. You just send your recommendation.
think through email you can send, keeping all in the loop, COE and chairman of DRC and the coordinator, PhD coordinator. So, and the guides, you take it in the loop and then send your recommendation.
Yes, sir.
Okay, fine.
So that would be a written communication since it is being conducted online.
Okay.
Kulvan sir, what you are saying?
Yeah, I believe DRC format will be there. A DRC form. In that, examiner sir also need to give the recommendation and along with the DRC.
Actually, yes.
Might be because recently Ankur viva has been done. So there was a DRC form were attached actually by the examiner, by the CE office.
I
So
think
how
DRC
this
chairman may confirm
format is signed by the external examiner? Is it required or not?
So I think that the digitally sign they after sign and scan copy examiner and send.
Yeah, I think in most of the universities that practice is there. You have some template and we put a signature on it and send a scanned copy to your office.
I will check actually what the document received actually from the CEO office with the comments. In that, some documents are there. I believe their CC also, HOD sir also in CC. I will check once again. Or directly recommendation also maybe send if you got direction from CEO office.
Okay.
So you will coordinate with COE office and you will do whatever with the evaluation process is. Because as a DRC chairman, I have asked to COE office whatever he is saying, I communicate it to the examiner. But if you are having some different opinion and some different experience, coordinate with the COE office, and I think you will send the recommendation of external examiner to COE office directly. Is it fine, sir?
No, we will send it to you only, DRC chairman.
Sir, whatever I have discussed with COE MUJ, whatever instruction he has given to me as a DRC chairman, I have passed it on to the examiner. But I think Kulwan sir is having some different exposure and different means experience. So according to that, if the evaluation will be in different mode, then it is fine.
Any viva voce form or something is there, I think, Shai. There is some viva voce format was there.
From my side, I think I am done. So you may discuss and whatever thing comes up, please just communicate by email. I'll accordingly act on it. Okay. I have to attend another meeting, so I am within a hurry. Okay.
Thank you, Professor Santosh.
Okay, sir. Thank you, sir.
Thank you, sir. Thank you.
Thank you very much for sparing your time. Thank you.
Thank you. Bye.
All right, Sajid. Thank you.
So, thank you. And congratulations to Himanshu. Dr. Himanshu.
So you can call Himanshu. Okay.